Alright, let's tackle the last subjects in this introductory session on deep learning, and that's going to be about backpropagation. Now, backpropagation is a fundamental algorithm in deep learning. Before we go into this more complex picture, I just want to make the reference to the previous lessons where we dealt with shallow learning. And I will show you that there's not so much of a difference with shallow and deep learning. And the main difference is the backpropagation. Yeah? So let's assume this is your machine, and again you feed your machine with a dataset that has features and labels. Remember the housing price prediction exercise? We had 6 samples of houses that were sold in the neighborhood of the house that we want to estimate the price for, and we want to estimate what a house of 350 square meter would cost. And we don't have a reference point here, so we don't know what the price will be. But what do we have? We have these 6 reference points, and we can decide to model these. Yeah? There's not so many options. And it's also obvious that the size and the price is a linear relationship. The higher the size, the higher the price. But there's no way I can find a line that goes through these 6 points. So what I did is I model. I take the best line, and the rest is like this. This is, I think, a good line, yeah, and this line, this is our model yPredict, and yPredict is a function of wx plus b, and here you see the w and the b, which are these w's and b's that we need to find. So this straight line is parameterized by w and b, and our goal is to find the w and the b for the best line. And how do we find best? Well, first of all, we take the prediction of y and we subtract the true y. And in this picture, that means that these are all these red vertical lines here. Yeah. So for example, this is 0.6, this is y6. And where it hits the line here, where it hits the line, this is yPredict 6. yPredict 6. Yeah? So basically you take these vertical red lines and you add them all up. But before you add them up, you square them. So that's a good measure, because the sum of all these red verticals will be the lowest if we have the best line. So that's why we decided to have an error or a cost function that models the imperfection of the model. And we've seen that the cost function for this case was 1 over m, the sum of yPredict minus y squared. So you take all these red verticals, you square, you sum them up, and you divide by m, and m is the sample size, and that's 6 in our case. Because for these 6 points we have size and price. Yeah. So now I define the linear model. Now I can see where it hits the line, and I can estimate my price. Now how does it work? Well, initially you start with some guesstimates of your W and your B. Let's assume it's W1 and B1. Now I will only draw it for W. B is a similar process, but I don't want to drag it along. So here you have your cost function here. It's a quadratic function, so it's going to have this shape, right? So you have a minimum. So basically what you want to end up is in W minimum. You want to end up. But let's assume you start here in W1. That's where you start. Now how you get to W minimum? Well, it's simple. Yeah. So in W1 you have a certain cost. Yeah. Which is this cost here. Yeah. And what you do now is you're going to calculate the derivative in that point. And the derivative in that point is equivalent to the slope in that point. So the derivative of the cost function with respect to W1 is negative. You see, this slope is negative. And then remember, there is an update rule that so W2 equals W1 minus alpha, derivative of cost function with respect to W1. And this alpha was the learning rate. Right? So if this dc to dW1 is negative, then together with this negative, the result will be W2 is W1 plus something. Plus something, that means you're gonna go to the right. Yeah? And you take a small step to the right, and this is then your W2. Yeah? So you go to W2 and B2. Again in W2 you calculate the derivative. Derivative is still going to be negative, so you take another step to the right. Yeah? And this will give you W3, B3. And this still you hit W minimum, B minimum. Yeah? This will be this minimum. And then at that point your cost is the lowest. Yeah? So that means that your Y predict is as close to Y as it can be. And that is where you reach the end of the algorithm. So this is just plain vanilla gradient descent. Now, on the deep learning side, I drew the situation of the coding exercise we just completed. It's the IMDb coding exercise. And here you also have an input and weights, and you have a Y predict and a Y, and you also have an error. Yeah? In this case, your error is also going to be proportional to Y predict minus Y squared. Is also quadratic. So you're also going to have such a curve. Yeah? But before we go into detail here, I need to give you another definition, and that definition is the chain rule. The chain rule in derivatives allows you to calculate the derivative of a nested function. What is a nested function? Well, you can have a function f that is function of another function g that is a function of x. So if I want to calculate the derivative of f with respect to x, I can't do it directly because this g is in the middle here. So the rule is that I go the f dg and then the g dx. Yeah? That is your chain rule. Okay? Very important. So you see here on the diagonal I have my g. And we will use the chain rule in order to show you how backpropagation works.